Let's begin. Today is September 14th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 3, 5, 9, 16, 19, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A looks at our middle digit, the square digit, and compares it to the number 3. So should the value of square be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at our first digit, the triangle digit, and will let us know whether it's an even digit or an odd. Criteria card C looks at our 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card D will look at the 3-digit solution, but this time it will let us know a little bit about the ratio of even to odds. So should there be more even than odds, or should there be less even than odds? Criteria card E will look at our first 2 digits, triangle and square, add them up, and compare it to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will again look at our 3-digit solution, but this time it will let us know whether there's a pair, as in the example 131, or alternatively no pairs, but there are 2 scenarios. One where all the digits are the same, as in the example 222, or all the digits are different, as in the example 134. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards. And we're going to begin with an initial proposal of 314. So the first thing I want to test is criteria card B. I want to know a little bit about that first digit. So the Turing Machine approves of my choice. I did pick an odd 3, so that means that the triangle digit is in fact an odd digit. So let's go ahead and type that up in our notes. So that triangle is an odd, an odd digit. Okay, and because it is odd, that means I can cross out all of the evens. So 2 and 4. The next thing I'd like to test is criteria card D. Okay, so criteria card D will let us know the ratio, and if you look at my proposal 314, I do have 2 odds to a single even. The Turing Machine does not approve of that, so it's basically telling me that there are in fact more even than odds. So let's go ahead and type that up in section D, and that is that there are more even than odds. Okay, so notice that since triangle is odd and we have more even than odds, that means that square and circle must both be even. So that means I can cross out all of my odds in triangle and, in square and circle. So we're basically looking at a solution that is odd, even, even. And of course, we do have this card, criteria card C, that will let us know whether there's a 3 or not. But I think I'd like to find out if those 2 evens are a pair or not. So let's go ahead and test criteria card F. Okay, so notice that in my proposal, all the digits are unique, are distinct, so that falls into the no pairs category. So that means that, in fact, there are no pairs. So let's go ahead and type that up in our notes for section F, and we'll say that the solution has no pairs. And of course it is of the variety of all unique digits. It can't be one digit repeated since we do have a mixture of even and odds. So that means we're either looking at two twos or a 2-4, but in some combination. Well, that does it for this round. We did complete our 3 Turing tests. We're now moving into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card A, comparing square with the number 3. Well, now it's a 50-50. It's either going to be less than 3 or greater than 3. And of course, that's going to force circle to be the other digit. And of course, we do have whether there's a 3 or not, and of course, the sum of the first 2 digits. So we know that the sum of the first 2 digits cannot be an even quantity. It's got to be an odd quantity, since we are dealing with odds and evens. So it can't be equal to 6 or, obviously 4. So it's either going to be a small odd or a large odd, comparing it with the number 6. So let's see. Yeah, so there are 3 varieties, I think, right? 1, 2, 1, 4, and 3, 2. Those are less than 6. And then, of course, 2, 5, 5, 2, 5, 4, and 3, 4. So it almost feels like, let's see. Well, again, we'll know what square will be as a 50-50. Then the question is, let's see, if it's a 2, then, it could be, well, maybe it's going to be a 4, because, well, I guess it could be either or, right? It could be small 1, 2, or 3, 2. Those are both less than, and then 3, 4, 5, 4 are greater than the 6. So, of course, the circle is just going to be forced. So let's see. If it's going to be less than, it almost feels like if it's going to be less than, well, that's not true, because you could have a 5, 2, and that's greater than. Yeah, there's always going to be a case where 4 can be added to 1 for a less than, and 2 can be added to 5 for a greater than. So let's go ahead. It just seems that, yeah, all these are going to be sort of 50-50. So let's go with a 3. Let's do 3, 4, 2. Okay, so let's go ahead and, yeah, well, let's see. Let's go ahead and test the sum. Let's go test E. Okay, so yes, the sum is greater than 6. So let's go ahead and type that up. And that, again, is in section E, and that triangle plus square needs to be greater than 6. And so that means it cannot be a 1 for triangle, and it could still be a 2 or 4. So let's see, what if we test whether there's a 3? Let's see, if there's a 3 or not, that's not going to make a difference. So I was hoping to deduce. If I know it's not a 3, if I know it's a 3, it's going to be a 4. If I don't know it's a 3, I don't know. So let's go ahead and test criteria card A. Okay, so it's also true that my choice for square is 4 and it's greater than. So it is a 4. Yeah, and that really didn't help us out. But let's go ahead and type it up all the same. And we're going to say that square is greater than 3. And of course that means it is a 4. So square is 4. And that means that circle is 2. But we still have to figure out, well, are we adding a 3 or a 5? So let's go ahead and test criteria card C. Okay, so it's there is no 3. So it looks like our solution is 5, 4, 2. And we did conclude that there is no 3-digit. Okay, well, let's go verify. So 5, 4, 2. So 5, 4, 2. Fantastic. Yes. Now let's see how we did versus a Turing machine. So we did test all the 3 criteria cards, and we did BDF in the first round and the remaining 3 in the second round, and each time the middle one was incorrect. So let's go ahead and type that up. BDF. So B was correct, D was incorrect, F was correct, and then we did the remaining 3. A was correct, C was incorrect, and E was correct. All right, so we beat the Turing machine by 1 question. Not sure how we got there. It was pretty straightforward. It almost seemed like each of the options was a 50-50, but it still was a very interesting puzzle. What do you think? Add your thoughts to the comments. If you saw an inefficiency on my part, if I could have improved it in some way, let me know. And of course, if you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, hit subscribe to be notified. Well, until next time, have a great one.